it seems only fair that you can pass closures as outputs from functions. Wait, it sounds a little weird, right? But if you can pass functions or closures as inputs to functions, how many times am I going to say the word functions here? It gets a little confusing, but if you can put functions into, oh my goodness. Okay, so you can do it like this. You can define a function that returns a function. Now, why would you want to do that? Usually you don't. For the most cases, if you've ever heard of the factory pattern, this is where that comes from, where you have this generator that you can call upon, you give it information, and then it creates sort of this like closure state that can then do things, it mutate over time. Every time you call the function, it's like a generator pattern. So it's sort of this factory creates a generator. Usually you never want to, there's no reason for this. You don't need, let's look. All right, let's walk through how we actually do that. It's a lot of fun, don't get me wrong. I really love doing it. I remember using it quite often, trying to make it really useful, but typically you just want to keep things simple. Rust, however, does let you do it. So closures as input parameters are possible. So if that's the case, then returning closures as outputs should also be possible. And it is. And you have to do that by implementing a trait. And we have 3 options. It looks like we have FnMut, and FnOnce. And here's a quick preview. At the bottom of the screen we're looking at, we have this implement function, and it returns a closure. This is really confusing, the syntax here. There's no semicolon, and there's these 2 bars, which, if you're used to programming, this is typically an OR operator. Do believe that even Rust has this as an OR operator, although in this case, it's just the start of a closure, right? You could also do it like this, I think. That'll probably work as well. And then even though the compiler could implicitly understand that we're returning a closure that is referencing other values here, you have to use the move keyword. It seems silly. Why would you create a function that returns a function? What are the possible reasons you want? I mean, there might be a few reasons. Well, before we dive into any reasons, let's look how we can do it. We can actually do that with Rust. On the screen here, we're looking at, actually, they make it pretty straightforward. It's actually a lot easier to write a function that returns a function. You only have to do these 2 things. You have to say implement fn, and then you have to say move and return a closure. Yes, actually, the syntax is pretty light. I do much appreciate that. I really like that. And I think you don't even need to use the move keyword if you're just returning a closure that doesn't reference anything. This is a print. Okay. Will it work? I don't know if it'll work. Do you think this will work? Do you think this will work right here? It looks super weird. Here, let's clean up that comment. All right, that's some weird syntax. It works. Hey, look at that. All right, so it compiled and it worked as designed. So here's a minimal code sample for writing a function that returns a function. And I'm all for it. I like low code when there's the least amount of syntax. Also, there's not too many symbols going on here, which is fantastic. And I like that ability to have minimal syntax. There is some readability, though it is very cryptic. Like, what is going on here? What is this OR operator doing here, right? That's an it's an OR operator. It's what we've all learned growing up. This is the OR operator. Well, in this case, it's not any different than these parentheses. It's these double pipe bars. But the double pipe bars represent the start of a closure, sometimes, right? Looking through the symbol list here, is there an OR operator? Oh, look at this. Oh, it's even short circuit OR operator. It's a logic operator OR, but it's missing something. It doesn't mention the closure syntax, does it? Let's see. Close. Oh, it does. Well, sort of. Just in case you run into the double pipe bars, they will mean something different based on the context. Here's a factory design pattern in Rust that you might find useful, or maybe not because it's a little overly. However, I kind of think of this as the hello world example for using a closure, where a closure could be useful when you return it from a function, sort of like the factory pattern. Right? We have a factory pattern. It's also a generator pattern that can be used to increment the number over time based on the number of times the function was called. You can track this internally in sort of its own system, but you could do that using other patterns in Rust, like with a struct and immutable element in the struct list. That's something that you could totally do. But you could also do that with closures, and this is how you kind of do it. Let's take a quick look here. So you have your factory function, which returns a mutable function. Inside of it has a variable that's in the scope called times, basically the number of times the function was called. It's mutable. Then we create a closure that is returned. We also have to put the move statement here. Man, even though the compiler probably could tell that, oh, okay, I probably will need to own it, because if you don't have this move statement, this data gets dropped, right? Our times variable will get dropped. And so you have to have this move statement here that says all the variables in the scope that we are within our function needs to get moved to the owned this section by value. So now it's permanently owned in this closure. And so every time we call the function we've returned, so it will increment our times variable and print out the number of times that we've printed. Looking at our main function, we have a mutable print closure that is assigned to our factory, and then we create our closure here, printed, and then we run it once and it's printed. So if we run this multiple times, we should see it's printed and it increment. Yes, okay, cool. I wasn't sure. I was pretty sure it was going to work, but I didn't know until just now. Look at that. Okay. So as you can see, you've created yourself a nice little pattern here that allows you to store state locally in this like nice little captured, variable that is able to be executed, and it keeps track of the number of times that you called upon it. Why would you want to do this? Would you do this? Would you do it this way? The syntax is it's satisfying. I do like it. It's very tasty. Would you do it though? Or would you use more traditional pattern like a struct where you've implemented a function on it that has a mutable element in the struct, which you can increment as needed and you just have an instance of, right? I don't know. Either way, we're trying to create a user experience, right? A user interface that is able to, give a good user experience, right? So we create some sort of structure, and then we can use that structure, right? Some sort of code logic. So we want to make it easy for the user. We want to make it minimal impact on the end user when they're leveraging your library. So that way it's just clean and simple for them and they have little to worry about. So all those internal mechanics can be taken care of behind the scenes. Although if we're looking at all this AI that can generate code for us and it keeps getting better, it seems like every day, like, look, it does even better now. It does even better. I guess it doesn't matter so much if our user experience that we've generated with our library gets much improved. Well, I don't know. We'll see. I guess we'll find out. Well, we kind of already know where it's going.